Hey guys, we are going to go ahead and continue with section 8.1.1. It does have a day 2 on it. So this section is all about how to start sketching graphs of functions. And it really is just about getting to know the shape. If you remember from the last video, we had to type our function into the calculator to know what the graph was going to do, how it was going to start, how it was going to end. And now we're going to learn how to know those things without the use of a calculator. So basically the end behavior of a function describes the behavior of the graph at the ends of the x-axis. So basically that's where it starts and where it ends. It's just on the left of the x-axis and the right. So I have a fun SpongeBob themed visual here for you to kind of get this idea across. Here, if you look at SpongeBob and Patrick's arms, they're both raised up towards the sky, right? So an example of this would be like a parabola, right? Because it starts going up and it ends going up. And you can see that if I just kind of draw it in here. And this would be called like up, up. All right. And then here, you can probably guess, now SpongeBob's arms are both pointing downwards. Okay, so this, maybe an upside down parabola would be an example of this, and you can call this down, down. All right, here we have another one. We have one arm on the left going downwards, and then we have the other one on the right going upwards. All right, so this would be called down, up. And we read graphs like we read a book, so left to right. That's why we start with down. And an example of this, actually cubic functions are a good down-up example. And then here, we have the first arm is up and the second arm is down. So this one is an up, down. All right. This one we could use another cubic function, but it would just be upside down. Okay, so just to give you an idea about what we're going to be working towards here. So, to find the method to the madness here. So this table is going to be a good way to sort all the different pieces you have to pay attention to when you're trying to figure out end behavior. So the two things that you have to focus on to figure that out are the leading coefficient, which we talked about earlier in 8.1.1, as well as the degree, which we also talked about earlier in 8.1.1. So if the leading coefficient is a positive number, and the degree is even, then we know our end behavior is going to be up, up. Okay, so we got up, up here. Okay, and these boxes are all just combinations of these ones. So this is even positive. And then here, if our leading coefficient is negative, but our degree is still even, then we are going to go ahead and say that this is going to be down, down. So both ends of our graph are going to be pointed downwards. Now for odd degrees, it's a little bit different. Now this is where we get into the up-downs. So when our degree is odd and our leading coefficient is positive, that's when you know you're going to have a down, up. Okay, so we're going to have a down and an up. Okay, and then for a negative leading coefficient with an odd degree, it's going to be like a flipped version of that. It's going to be up, down. So the left side's going to be pointed up and the right side's going to be pointed down. And on the next page here, I've also given you another visual to look at. Some people really like this visual. It has some examples as well. So just make sure you pay attention to the fact that this table is a little switched. Here the degree is at the top and the leading coefficient is on the left. but it has the same concept. So when you have an even degree and a positive leading coefficient, then you're going to be up, up. And an example of that is y equals x squared, because this leading coefficient is 1, which is in a positive number because there's no negative sign, and the degree is 2, which is an even number. Okay, or here, x to the 9th, it's an odd degree because the number 9 is odd, and it's positive because there is no negative sign up front. Okay, and then down here, this is where we get into the negative leading coefficients. So if you have a negative sign up front and the degree is an even number, that would be your down, down. And then similarly here, we have a negative up front, so the leading coefficient is negative, but the degree is odd. And that tells us that we're going to be up, down. So this table is also really helpful to put that all together. So let's go ahead and try some examples of how to use this. So here are some polynomials. We're just going to go ahead and look at the leading coefficient, whether it's positive or negative, find out if the degree is even or odd, and then make our decision accordingly. So the leading coefficient, as we talked about before, if there's no number up here, it's just automatically a 1, but we don't care about the number as much as we care about the sign. So since there's no negative out here, we're going to go ahead and say that it's positive. If there was a negative, that's when it would be negative. Okay, and the degree, we have 1x here, and we have an x squared here. So x times x squared, that gives us an x cubed, which means that our degree is 3. 3 is indeed an odd number, so we're going to say that we have an odd degree. Okay, now let's go ahead and look back at our table. We have a positive leading coefficient and an odd degree. Positive, odd, that tells us that we are going to be down, up. And we can look at this table too. Odd degree, positive leading coefficient, down, up. So we will write down, up. All right, let's go ahead and try another one. Here, this time our leading coefficient actually is going to be a negative number because it has a negative up in front of the parentheses. So negative. And the x's here, we have 1, 2, 3. There is an x squared just like the last one. So again, we have x times x squared gives us an x cubed, and this is our degree. So once again, we have a degree of 3, which is odd still. And now that it's a negative odd, we can go back to our table and find that negative odd gives us up, down. And again, this to find that on this table, you go to odd and negative, and then find the box where that's the combination. So we will go ahead and write up, down. Okay, moving on to the next one. Here it's in standard form now, so to change it up a little bit, the leading coefficient is the number attached to the term with the degree. So really for all of this, we're just going to be paying attention to this term. The leading coefficient is positive because there's no negative sign here. And then the degree is 4, which is an even number. So we'll put even. And so positive, even. We move back here to find that positive even gives us an up, up end behavior. So we will go ahead and write up, up. Okay, and one last example here. Notice that there is a negative sign out front. If we were to factor that negative sign into this whole polynomial, we could actually rewrite it as negative x to the 4th minus 2x to the 3rd. It would change all the signs on everything. So anything positive will turn negative, anything negative will turn positive. So plus 13x squared plus 14x minus 24. And again, we just changed all the signs because of this negative out front. So this tells us, now again, we're paying attention to this term, the leading coefficient is a -1. So that's where a negative's coming from. And the degree is 4, once again, just like the last one. So it's an even number. Okay, and negative even, that's going to be similar to this one, it's just the opposite. It's going to be down, down. And again, you can refer back to your table to figure that one out. And that is pretty much the gist of end behavior, just focusing on that first term and looking at whether there's a negative sign and figuring out whether the degree is positive or if it's negative. That's all. And this one is going to be all about some vocabulary. You might have heard me use these words throughout the school year, and it might seem like they're interchangeable, and that's because they're very similar, and they kind of allude to similar things, but there are situations where, you got to use one or the other. So it's really important for your own knowledge and also for the MyOpen math problems that you know how to distinguish between these guys. So starting with roots. Now, what I'll point out right away is that roots and zeros are actually the same exact thing, so you can make a note of that. Okay. And what they are is the numbers that are going to make your equation equal 0 when you plug them in. And based on the zero product property that we used early on, we know that in order to figure out what would make our equation equal to 0, all we got to do is set each factor equal to 0 and solve. So when you do this one, you add 2 to both sides, you get an answer of 2. And when you do this one, you subtract 1 from both sides, and you get -1. So we know that our roots are going to be 2 and -1. Now, something to notice is that this x plus 1 factor has an exponent of 2. So technically, we should name that root twice. All right, so now zeros, like I said, it's the same exact thing. The name zeros is actually just more convenient because it's a lot more obvious, right? We're literally looking for the numbers where when you plug them into the equation, you get an answer of zeros. So, well, 0. So that is that for those two. Now the x-intercepts, that is where your graph is going to hit your x-axis. So you actually are going to use your zeros to form these. We know that x-intercepts are always some number, comma 0 for the y value because they're literally on the axis. They don't move up or down. And we just have to use the zeros to fill those in. So we have one x-intercept at 2, 0, and we have another one at -1, 0. For this one, we don't have to list that second one because it's literally talking about a coordinate point on the graph, and so we only have to talk about that once. And lastly, for factors, this is very conveniently already in factored form, and so we know our factors are x minus 2 and x plus 1. Okay, and we can even list x plus 1 twice because there are 2 of them technically, right? In our equation, if there's an x plus 1 squared, that's the same thing as saying that there's an x plus 1 times another x plus 1. All right, so figuring out this information from factored form is relatively simple. And when you go to standard form, like we have here, it changes a little bit, but that is what our calculator is for. So recall from the last video that when things are in standard form, it's a lot harder to find some pieces of information. And so typing those in your calculator to graph them comes in handy. So we're just going to go ahead and type out that equation as we see it. Oh, yikes. Let's try this again. Oh my goodness. Starting to wonder why I chose such a long equation. 24. Okay, so let's just check to make sure we wrote it right. X to the fourth plus 2x cubed minus 13x squared minus 14x plus 24. That looks right. And let's go ahead and graph that. All right, and I do like to look at things in the standard zoom, so I'm going to go ahead and hit zoom and go to that sixth option where it says zoom standard. This will give us a nice 10 by 10 view. So to find the x-intercepts first will be the easiest. So because we're in zoom standard, we can actually just count the tick marks, because in zoom standard on our graph, every tick mark, it just changes by 1. So our first x-intercept, if we look, there's 1, 2, 3, 4. This is on the 4th tick mark, and so we know that one of our x-intercepts is going to be at -4, 0. Okay, and if we look here, it's at the 1, 2, second tick mark. So we have a -2, 0. The next one is at +1. And the final one is at 1, 2, 3, so 3, 0. All right, once we find all the x-intercepts, we can just use those to find the rest of this information. So if you look at our previous example, notice how the zeros and roots were actually the same numbers as our x-intercepts, or at least the x-values of our x-intercepts. So we know just by looking at the numbers in the x-value for these points, our roots are -4, -2, 1, and 3. And again, we just use those same values for zeros. Okay, nice and easy. And for factors, now notice here we really were able to just take them from the problem, but we can't do that here. However, it's important to see that the factors have the opposite signs as our actual x-intercepts, right? So our x minus 2 went with our 2, 0. X plus 1 goes with -1, 0. So we're taking the opposite for our factors. That -4, 0 is going to give us a factor of x plus 4. -2, 0 will give us a factor of x plus 2. 1, 0 will give us x minus 1. And lastly, that 3, 0 will give us a factor of x minus 3. Again, we are taking the opposite of this number when we're writing it in our factor. Okay, and lastly, all we have to do is take these factors and kind of arrange them like we saw in this problem, because this is in factored form, and that's exactly what we want here. So I will just go ahead and write my f of x and say that f of x is equal to x plus 4 times x plus 2 times x minus 1 times x minus 3. I literally just took all of these factors and stuck them in my equation. And that is it.